Okay, section 7.5, these are complex fractions, which in my opinion is a misnomer. They really shouldn't be called complex fractions because some of you may be thinking of like like the square root of -1 is I. This has nothing to do with that, so there's no imaginary numbers here. So these really should be called compound fractions, meaning fractions within fractions. But okay, so the book calls them complex fractions. That's the way it is in most books. But complex meaning complicated or compound fractions, right? So a compound fraction is really just when you have fractions within fractions. And this is a perfectly good example here, right? In example 1, we have a fraction in the numerator, 2 over 15, and a fraction in the denominator, 8 over 25. Right? So this is a compound or complex fraction. So how do we simplify it? Well, there's actually two ways of doing it, right? And we're going to concentrate for now on method 1, or the book calls it method 1. I just call it dividing fractions, right? Because this is really just dividing two fractions, right? So the first step is to simplify the numerator and denominator, and there's really nothing to simplify here. Typically what that means is if you have a fraction where you're adding fractions or subtracting fractions, either in the numerator or denominator, then you have to add or subtract all those fractions, right? And we did that in the last section, 7.5. Luckily here, the numerator is a single fraction, the denominator is a single fraction, and so there's nothing to simplify here. Okay. So after you do that simplifying, the result should be a fraction divided by a fraction. In fact, we have that already, right? In other words, it should look like this. You should have a over b and then over c over d. But that's the same thing as a over b, right? That's a b, divided by c over d. And how do you divide fractions? Well, we did that way back in section 7.2. Remember, we were multiplying and dividing fractions. When you divide fractions, you have to multiply by the reciprocal. Remember that? Remember keep, change, flip? Oops. Keep the first fraction, change this to multiply, and then flip the second fraction, right? So we kept the first fraction, we changed this to multiply, and then c over d, when you flip it, you take the reciprocal, you get d over c, right? And then you just simplify, right? If there's anything to simplify, you factor and cancel. All right, so now let's go back to the original problem. This is my a over b over c over d. So we're just going to write it as a division problem, 2 over 15 divided by 8 over 25. Okay, so keep the first fraction, 2 over 15, change division to multiply, so I'll use a dot for multiply, and then flip the second fraction. The second fraction, instead of 8 over 25, when you flip it, becomes 25 over 8. Okay so far? All right, so now how do we multiply these fractions? Well, multiplying is easy, right? Multiply straight across. So this is 2 times 25 all over 15 times 8. Okay. Now, you might wonder why didn't I can do that in my head. Why didn't I just do 2 times 25 is 50 divided by 15 times 8? Oh, I have to think about that for a second. I think that's 120. 15 times 8. You're welcome to use your calculator, of course. Yep, 120. All right. So why didn't I do that? Well, I just did, I guess. But one reason why you probably don't want to do this is because this is clearly not in lowest terms, right? So how do you reduce this to its lowest terms? Well, you factor, so 50 is just 5 times 10. And 12 is 12 times, 120 rather, is 12 times 10. So you get your common factor of 10, you can cancel those, and you end up with, I just have enough room, 5 over 12. And that's the answer, right? Now, that's one way of doing it. The other way is, if you left it like this, you recognize that, hey, 25 is just 5 times 5, and 15 is 3 times 5, right? And what's 8? 8 is 2 times 4. So, right, so by factoring these, rather than getting big numbers, you get smaller numbers. And they're all factors, so we can cancel one of the 5s and also one of the 2s. There's a 2 on top, there's a 2 on the bottom. So after you cancel those rather, you just get a 5 on top, and then 3 times 4, well, that's just 12. So you end up with the same answer. Right? So it turns out we could have done it either way. I generally prefer not to multiply these out and get big numbers. I'd prefer to factor them to get smaller numbers and then just cancel the smaller numbers, right? So you can see why we cancel the 10 here. We cancel 2 times 5 or 5 times 2. Okay, so I hope that helps. Again, this was probably an easy one because it's just involving numbers, but that's the idea here, right? So now we're going to look at another one. Okay, so here's our second example. We have 8x over x minus 5 over 2x cubed over x minus 5. So first thing I'm just going to do is copy it down so it's clear to everyone. We have 8x over x minus 5 over 2x cubed divided by x minus 5. Okay, so there's really nothing to simplify here. This is a over b over c over d, right? So there's nothing to add in the numerators. There's nothing to subtract in the numerators. This is just dividing 2 fractions, right? So we're dividing the numerator, 8x over x minus 5, divided by the denominator is 2x cubed divided by x minus 5. Okay, so now the second step, keep, change, flip, right? So keep the first fraction, change this to multiply, and then flip the second fraction. Okay. All right. So how do you multiply? Straight across. Don't forget parentheses here. So we have 8x times x minus 5 over, I'm going to actually put the 2x cubed in front, 2x cubed, right, times x minus 5 in back. You can see why I did that, right? We're going to end up canceling the x minus 5s. In fact, if you want to do it now, you can, because, again, you're just multiplying here, right? We're not adding or subtracting these. So as factors, they cancel. And what are we left with? Well, we're left with, in the numerator, 8x, and in the denominator, 2x cubed. So this should be easy to simplify. 8 divided by 2 is 4, so this is going to be 4 in the numerator. And we can cancel one of these x's, leaving 2 of them on the bottom. So 4 over x squared. Now, maybe I did that a little fast. So let's think about this another way, right? We know 8 is just 2 times 2 times 2, or let's just do 2 times 4 times x. And in the denominator, we have 2 times x times x times x, right? X cubed is x times x times x. So thinking of it that way, 2 divided by 2 is 1, so they cancel. And x divided by x is also 1, so they cancel. Well, what does that leave us with? 4 on the top. Sorry, 4, not a 9. That's a 4. Let me try that again. 4 over x times x. X times x is also x squared. So same answer. Again, I was doing this in my head, but for some of you it might be helpful to actually write it all out. So that's the answer, 4 over x squared. Right? We're done. Okay, so moving on to, I think this is our third example. Sorry, I didn't label the last one. So here we're going to divide 1 plus 2 over x, and then over x plus 8 over x squared. All right, so again, I'm going to write down the problem. Just, that looks right. So it's a 1 plus 2 over x, right? And then all of that over x plus 8 over x squared. Okay. So remember I said there's 2 ways of doing this. We're still going to use the first method, although I happen to think the second method works a little bit easier here. But just to show you that, right, the problems we did already using this method worked out great because the numerator and denominator were already fractions. They're already a over b and c over d. Remember, that's the idea of what we're looking for here. We're looking for a over b over c over d. And unfortunately, we don't have that, right? This numerator here, this is not one fraction. It's two fractions, right? It's 1 over 1, if you will, plus 2 over x. And this is also not one fraction. It's two fractions, x over 1, if you will, plus 8 over x squared. Okay, so this one's going to be a little trickier because here we actually have to add the fraction to the numerator. So step 1, simplify. That's going to look like this, right? So this is my step 1. We have 1 over 1 plus 2 over x. So how do we add these two fractions? Well, we need a common denominator, right? What's our LCD here? We have a 1 and an x. So 1 times x is just x. So the LCD for the numerators, again, we'll do the denominators later. Right now, we're just adding the numerators here. Right, the LCD is x, so I need both of these to be x. Well, this one's already an x, but this isn't. So here, I need to multiply top and bottom by x. Okay, and now when I do that, oh, hang on a second, because I think I have a little too much space here. Yeah. Oops. Let me try that again. Let's try that again. All right. There we go. Sorry about that. So where were we, right? We're doing x over x plus 2 over x. And now that we have the same denominator, we just add the numerators, right? We get x plus 2 over x. Okay. So we simplified the numerator, right? Now we got to do it all over again with the denominator, right? This is really x over 1 plus 8 over x squared. So how do we add these two fractions? Well, same way we did it here. What's the LCD? 1 times x squared. So the biggest power of x is x squared. My LCD is x squared. So this being the LCD, we don't have to change that. That's already x squared. But we need an x squared in the denominator here. So I'm going to multiply denominator by x squared and the numerator by x squared. Right? So now when we do that, I get x. Oh, sorry. That's that should be a 2, right? X squared over x squared. I'm getting ahead of myself, right? So when you multiply x times x squared, you do get x cubed. And when you multiply 1 times x squared, you get x squared. And the second fraction is just 8 over x squared. No problem there. Now that we have the same denominator, right, we just add the numerators, x cubed plus 8. Okay, so now this was step 1. We simplified the numerators, we simplified the denominators. Now we have our a over b, right? So we have a over b divided by c over d. This is my a, this is my b, this is my c, this is my d. Okay. Okay. So you notice I got rid of the a over b over c over d here. Because now we move on to step 2. So step 2. So let me just copy this down here. We have x plus 2 over x cubed plus 8 divided by x squared. So a over b over c over d. So step 2, divide the fractions, right? So we divide the numerator by the denominator. Right? And now change flip. So keep the first fraction. Change this to multiply instead of dividing, or now multiplying. And now flip the second fraction. When you flip it, you get x squared over x cubed plus 8. Okay. And how do you multiply fractions? Just straight across, right? We have x plus 2 times x squared all over x times x cubed plus 8. Okay, so far, right? Yeah, so notice that the numerator, x squared, is really just x times x. So one of the x's cancels. If you like, you can write it as x plus 2 times x over x. Now, you don't need parentheses here, but just to make this easier to see, I'll put in parentheses around it. And then x cubed plus 8 is still there, right? So what I'm trying to tell you is that one of these x's, this x and this x, for example, just cancel, right? And now what are we left with? In the numerator, we have x plus 2 times x. And in the denominator, just x cubed plus 8. Okay. So, are we done? Well, remember what simplify means, right? This is canceling. We did cancel the x's. Maybe a little prematurely. Maybe we should have waited for that. But we did cancel those. However, simplify also means factor and cancel. So the numerator is already factored. What about the denominator here? Right, so what about this x cubed plus 8? Can we factor that? Yeah, we can. This is one of the harder ones, but you might remember a cubed plus b cubed factors as a plus b times a squared minus ab plus b squared. And in this case, our a, capital A, is just x, and our capital B is not 8, right? It's the cube root of 8. b cubed, right, is 2 cubed, which is 8. So b is 2, a is x. So that means, we get x plus 2 times x squared minus x times 2, or 2 times x, plus 2 squared. 2 squared is 4. All right, so that's the denominator. And when I factor it, well, I just did that, right? But let me just copy it down here. This factors as x plus 2 times x squared minus 2x plus 4. Well, now, having factored that, you notice we have another common factor, right? This x plus 2 here, x plus 2 is a factor of the numerator, it's a factor of the denominator, so they cancel. And what do you get after they cancel? The numerator is just x, the parentheses are optional here, and we divide by x squared minus 2x plus 4. Right. And if you remember, if you're looking to factor this, remember this, when it comes from the sum and difference of cubes here, is not factorable. This is going to be prime. You know, what two numbers multiply to 4 and add to negative 2? There aren't any. So luckily, you could leave this alone. You don't have to bother trying to factor it. But that's our final answer here. Okay? So as I think originally told you that there is another way to do this using method 2, and in fact I might just do that using method 2. So we're going to do the same problem in just a second using the second method, and you'll see it's maybe a little bit easier than this, or at least I hope so. Okay, so yeah, same problem as before, but now using a different method. Right? And to be fair, if you're really comfortable with method 1, you don't need to learn this. It's good to know both ways of doing it, but you could get by with just one way or the other. And so what I had in method 1, way up here, method 1, you can always use that, right? And none of the questions are going to say you have to use this method or you have to use this method here. You do it whichever way you want. Right? I'm just giving you two options here. Okay, So we have the same problem as before, right? This is 1 plus 2 over x divided by x plus 8 over x squared. Okay. Right. So in this method here, I call it multiplying by 1. So we're going to find the LCD of all the individual denominators. So let's first rewrite this. This is 1 over 1 plus 2 over x, and then x over 1 plus 8 over x squared. Right? So we actually have 4 denominators here, right? We have a 1, an x, a 1, and an x. So we're looking for the LCD out of 1, 1, x, x squared. So out of these 4 things, what's the LCD? Well, we have a 1, of course, times x. Remember the rule? We pick the bigger exponent. So out of the 1 and the 2 here, what's bigger? 2. So 1 times x squared is just x squared. So our LCD is x squared. Right? So we're finding the LCD out of all 4 denominators here, all 4 of these. Right? So don't get confused with just the top or just the bottom. Okay? Okay. Well, if that's the LCD, what do we do with that? In step 2, it says to multiply numerator and denominator by the LCD. Well, here's the numerator. This whole thing is the numerator, and this whole thing is the denominator. We're going to multiply numerator and denominator by the LCD. So we're going to multiply the numerator by x squared and the denominator by x squared, because that's the LCD. Right? But what we're really doing is multiplying the numerator of the numerator and the numerator of the denominator by x squared. So we're not dividing by x squared over x squared over x squared over x squared, right? We're dividing by x squared by x squared. Okay? So when we do that, what happens? So notice that this is a factor. It multiplies both of these. So we have to distribute this. We get 1 times x squared, which is x squared, over 1 times 1 is 1, plus 2 times x squared, so that's 2x squared, over x times 1, which is x. And then do the same thing in the denominator here, right? We have x squared times x, which is x cubed, divided by 1 times 1, which is 1, plus, because that's a plus, right? That's a plus. 8 times x squared is 8x squared, over x squared times 1 is just x squared. Okay, so at this stage, you do get kind of a mess here, right? However, we can simplify this, right? So that's the simplify part here. Simplify by just canceling what we can cancel. Remember, x squared, you can think of that as just x times x, which means one of these x's cancels. Right? Here, we have x squared divided by x squared. So here, both of the x's cancel. Right? And when you do that, you're left with x squared on the numerator. Now, this is x squared over 1, so I don't need the 1 here, plus 2 times x. Right? 2 times x. Remember, only one of the x's canceled, leaving you with another x. And in the denominator, we have x cubed. Again, we don't need the 1 now, because this is also a 1 here, right? Plus, this is an 8. We canceled both x's, so there's just 8 left over. Let me try that again. 8. Okay. All right. So that's part of simplifying, but we have one more thing to do here. Factor and cancel, right? So factor out an x on the top. And x cubed plus 8, well, we know how to factor that, right? That's just the usual a cubed plus b cubed. We did that already, so I'll spare you the details there. It's just x squared. It's x plus 2 times x squared minus 2x plus 4. So you can go back, or here it is again, right? X cubed plus 8 factors as x plus 2 times x squared minus 2x plus 4, and that came from the a cubed plus b cubed. Okay. All right. Well, now notice that we have a factor of x plus 2 in the numerator and an x plus 2 in the denominator. They cancel, leaving you with, and I'll write it over here, x in the numerator and then x squared minus 2x plus 4 in the denominator. Parentheses are optional. And that's our answer. Right. So if you notice, we did this already, and we got the same answer here. X over x squared minus 2x plus 4 is the same as x over x squared minus 2x plus 4. Same answer. Just doing it a slightly different way. So if you like this way better, great. You can use this method. If you prefer this way, and you can see why I kind of don't prefer it, it's a lot more work. This took a lot longer. Step 1 itself was like adding fractions twice, right? Once in the numerator, once in the denominator, and so on. So I found this to be a little more cumbersome. This is a little bit cleaner, and a little bit faster, I think. Right. So it really depends, right? It depends on how the original problem is expressed. If this were already a single fraction, right? In other words, if this was already one fraction and this was already one fraction, then method 1 probably works better. But if you have to add or subtract, fractions in the numerator and or the denominator, then you're probably better off using method 2 here. So those are the two different methods in section 7.5, right? So method 1 and then method 2. So I think I'll do one more example, and then we'll move on to the next section. Okay, so here's our last example in this section, 7.5. We're going to simplify. So example 4 is to simplify this complex fraction, compound fraction, either way. So we have 1, let me copy it down, 1 minus 9 over p squared, and then all of that divided by 1 minus 1 over p minus 6 over p squared. Okay, so what do you think would be easier here, method 1 or 2? So in method 1, we can't just divide the fractions yet. We'd have to subtract these two fractions here. And in the denominator, we have to actually subtract 3 fractions. So to me, that seems like a lot of work. You can do it. It's not that bad, but it's a lot of work. So I would actually prefer method 2 here, right? Because finding the LCD here is really not that bad. Let me just rewrite the numerator as 1 over 1 minus 9 over p squared. And we have 1 over 1 minus 1 over p. Sorry, that's a 1 over p. And then minus 6 over p squared. So, right, so in method 2, we have to find the LCD. And there's actually 5 denominators here. There's a 1, there's a p, there's another 1 here, and then there's another p, and then there's a p squared here. Oh, I'm sorry, this is p squared. Well, the LCD, of course, is just p squared. It's the p with the biggest power. So p squared is our LCD. Right? So in method 2, we just multiply top and bottom by p squared. Okay. Now, the tricky thing is, remember, you have to distribute these, right, over each term. And so let's do that here. So 1 times p squared is p squared divided by 1 times 1, which is 1, minus 9p squared, over p squared times 1, which is p squared. And I think I'm quickly going to run out of room here. Right? And now we do the same thing to the denominator. We have p squared times 1, which is p squared, over 1 times 1, minus p squared over p, right? P times 1, yep. And then minus 6 times p squared, all over p squared times 1. Okay. Well, yeah, I know it's a mess, right? But that's what you get after you multiply this out, right? The nice thing, of course, is that you're going to simplify. Right? P squared divided by P squared is 1, so they cancel. Same thing here, P squared divided by P squared is 1, so they cancel. And P squared divided by P is just P. I know I'm cheating a little bit here, but remember, P squared is P times P, and so you cancel one of the P's, leaving you with one left over. So, all right. So the numerator is really just P squared minus 9. The denominator is P squared, again, over 1, minus P over 1, minus 6. Okay. And that's just an exponent of 2. Oops. I think that's better. All right. So that's it. So now at least it's a single fraction, right? In other words, it's a simple fraction. It's just a numerator and a denominator. However, we're not quite done yet because remember what simplify also means. Factor and cancel. So factor, how do we factor the numerator? Well, that should remind you of difference of squares, a squared minus b squared. A is p, b is 3. So a minus b times a plus b. Right? Here it is again. Right, so a is p, b is 3, right? Square root of 9 is 3, right? All right, what about the denominator? GCF is 1, so let's just factor AC method, or better yet, what two numbers multiply to negative 6 and add to negative 1? So I think it's 3 and 2. So where do we put the plus sign? We want negative 3 plus 2, right, to get negative 1. Okay, so I think that does it here. I'm running out of space, so let's move down a little bit here. We're really almost done. That's the factoring part. Remember, the other part was cancel. What are we canceling here? The only factor that cancels is this, the p minus 3 on top and the p minus 3 on the bottom. So we cancel those, and we end up with, in the numerator, p plus 3, and in the denominator, p plus 2. And now we're finally done. Okay, so I think that should be the final answer, right? Well, unless you're tempted to cancel the p's here, please don't do that. We know that's wrong. You cannot cancel terms, right? You're not multiplying p times 3. It's p plus 3 and p plus 2. Why could we cancel these? Because here you're multiplying, right? You can cancel factors, not terms. You can cancel things that you multiply, right? But not things that you add or subtract. So I hope that helps. And I think that does it for 7.5.